In this video, we're going to look at what would be considered a challenging calculus optimization question on a Math Studies IB exam. So these questions look a lot more intimidating than they actually are, so don't be afraid of them. Just jump in and do your best. All right, so in this particular question, we have a lobster trap and we have a half a cylinder, and it's constructed from a steel frame. So the steel frame are those bold lines that you can see here and here, here, and around here. All of these bold lines are the steel frame that makes up the lobster trap. So in part A, we're just asked to write down an expression for T in terms of R, L, and pi. So when it says in terms of, it just means that in our answer we're going to have R, we're going to have L, and we're going to have pi. It's not going to be a direct one value. It's going to be a term with R's, L's, and pi's, and maybe some numbers in it, and that's totally okay. So I am going to use different colors to trace out the different parts of our frame. So we have R right here, and our figure is symmetric, so we have another R right here. And in the back, we have another R right here, and we have another R right here. So I just counted out, I'll erase and show you again. I just counted out 1R, 2R, 3R, 4R. There are 4 R's in our frame. All right, so that's just that red part, but there's a lot more to our frame. So let's, in blue, trace out our lengths. So we have a length right here, 1L. There's another here, 2L. Another here, 3L. And one more up here, 4L. So all those lengths are the same, and they all add up to 4L. But that's not our entire frame. We have one more part to our frame, and we need to get that down as well. So that half a circle right here that's a half a circle, and there's actually another half a circle in the back. Now when you put two half circles together, what do you get? That's right, you get a whole circle. Now we need the length going around a whole circle, and there's a word for that. If you said the word circumference, you are correct. So we are looking for the circumference of a circle, but again, we don't have any numbers, which makes it seem hard, but it's not. We just need an expression, and an expression for circumference is 2 pi r, and that's sufficient, 2 pi r. So the sum of all our lengths, the red part, which is 4R, the blue part, which is 4L, and our circle in lilac here, which is 2 pi r, the sum of all those three things will give us our expression for T. So T is equal to 4R plus 4L plus 2 pi r. Okay, so now we're being asked for the volume of our lobster trap. So they're actually telling us the volume of the lobster trap is 0.75 meter cube, and they're asking for an equation in terms of R, L, and pi. So again, it means that R, L, and pi will be in our answer, and that's totally okay. Now, what is the shape of our lobster trap? Well, if you said it looks kind of like a cylinder cut in half, then you are right. It is a cylinder cut in half. See, if I had, a bottom part here, that would kind of make it a whole cylinder. But that's not what it is. It's a half a cylinder. Okay, so what is the volume of a whole cylinder? First of all, you might want to look at your formula sheet if you don't remember, and you'll see that the volume of a cylinder, an entire cylinder, is equal to pi r squared times h. All right, so we don't have an entire cylinder. We have a half a cylinder. So the volume of our half a cylinder would be pi r squared times h over 2. Now, the question said, give the answer in terms of r, l, and pi. Well, I have here r, h, and pi. What's the problem with the h? Well, if you notice here, or length is the height of our cylinder. It's not called h in this question. It just so happens that in this particular question, it's called L. So the volume of our half a cylinder is actually pi r squared L over 2. And, well, as we know, as we were told before this part of the question started, the volume of this cylinder is 0.75 meters cubed, which means that our volume, 0.75 meters cubed, is equal to that expression, pi r squared L over 2, that we just came up with. And that is our answer for part B. We've given an equation, because there's an equal sign, for the volume in terms of R, L, and pi. Okay, so now they're asking us to show that T is equal to all this here. All right, well, this looks a lot harder than it is, like the rest of the question. It just looks like a scary thing, which it's not that bad. Notice that there is a pi and there's a r here in our expression for T. And earlier when we started the question, we had an expression for T. There was a r, there was a L, which there's no L here, and there was a pi and an r again. Okay, so the difference between our original expression for T, which we have up top here, and their expression for T is that ours has an L and theirs doesn't. That's a major, major difference. All right, so that means that somehow we have to get the L out of this equation. How do we go about doing that? Well, a hint is these questions are very, very much chronological. Like they probably asked us to do part B for a reason. So if we take a look at our answer in B, if we take a look at our answer for B here, we have an expression for volume and there's an L there. Well, it would be very, very easy for us to isolate that L. Why would we want to isolate that L? Well, if we have an expression for L, we can probably just put it in that spot right there. So let's see it happen. All right. So we have 0.75 equals pi r squared L over 2. If I multiply 2 by both sides, let me use a different color so we can see it happen. If I multiply 2 by both sides, I will get that 1.5 is equal to pi r squared L. Now if I take that and divide both sides by pi r squared, I will get an expression for L. And my expression for L will be L is equal to 1.5 over pi r squared. All right, how does that help us? Well, we are trying to get to this point. So I'm going to take this and I'm going to move it to the bottom of the page because that's where we're trying to end up. All right, so I can now take our expression for L, which is right here, and I can substitute it into our original spot that L was. So I'm going to take that L out and put that expression that's written here in its place. So originally, when we did question A, we got that T was equal to 4R plus 4L plus 2 pi r. That's what I have in the first line. That's what we did originally. But again, we don't want our L. there. So I'm going to say that t instead is equal to 4r, which I just rewrote, plus 4 times. And again, I'm taking this and I'm putting it in the spot where L is. So that is, let's say, 1.5 over pi r squared plus 2 pi r. So now we no longer have any L's. So we are trying to get what we currently have to look like what they want us to show. All right, so in good faith, we're going to just keep moving forward and see what happens. All right, so we have t equals 4r plus 4 times 1.5 is 6, so that's 6 over pi r squared plus 2 pi r. All right, now looking at this, we have some similarities here. For example, we have the 6 over pi r squared here and the 6 over pi r squared here. The thing that doesn't look exactly the same, well, this is here and that, well, I'm guessing must be related. So these two things must be related to that. So I'm going to move them closer together, 4r and 2 pi r. We get t equals 4r plus 2 pi r. So I just took these two things and moved them together so it could look more like that. Plus 6 over pi r squared. That I just rewrote. Now it's starting to look very similar to this. If I take out a common factor here between these two terms, r, what would happen? Well, I would get that t is equal to r, so I'm taking out that common factor, and I'm dividing 4r by r, and I get 4 plus 2 pi. So I just divided that by r, and I got 2 pi. Now, our 6 over pi r squared is okay already. It's exactly what we need it to be. And I think we are there. If we just now reorder this, t equals, if I just take this r, put it on the side, take this 2 pi and 4 and switch the order around a bit, then I get exactly what they want us to have, which is that t is equal to 2 pi plus 4 r plus 6 over pi r squared. So we've shown what they want us to show, and we are done with C. Okay, so up until this point, you've actually done no calculus. Basically, all that's happened is you've done some geometry, you've done some algebraic manipulation. So a really strong ninth grade student who's taken geometry and algebra, who is really confident, could have probably done A, B, and C. But that's not to say they're easy. It's just to say that the algebra and geometry is all that has happened so far. So at this point, the calculus starts. So they're asking us to find dt over dr. That's comparable to asking us to find dy over dx. It just so happens that in this particular question, our y happens to be t and our x happens to be r. So just think of this as our y, this as our x. We're really differentiating as we always do. So in this question, it looks super complicated, but remember that this 2 pi plus 4 is just a number. It could be 10, it could be 20, it could be just any random number, and we're going to treat it that way. And we have a fraction going on here. That's a little bit annoying, but that's okay because we know that before we differentiate, we can pull that r squared up, and all that happens is that the sign of the r squared changes. So let's go ahead and do that before we differentiate. 2 pi plus 4 r plus 6 over pi. Again, I'm only moving the r up, and so the square becomes -2, raised to the -2. Now we're ready to differentiate. So dt over dr. So remember that if you differentiated 5x, it would become 5. If you differentiate a million x, it just becomes a million. So when you differentiate 2 pi plus 4r, it just becomes 2 pi plus 4. Now, I'm not going over the rules of differentiation in detail. Hopefully that's something you remember. All right. And when you differentiate the expression on your right, we're multiplying our negative 2 by 6 over pi to get our new coefficient, which is minus 12 over pi r, and then we're subtracting 1 from our exponent to get negative 3. Once that's done, we can pull back our r to the negative 3 back down to the denominator, and it will make our exponent positive once again. So 2 pi plus 4, just rewriting, minus 12 over pi r to the third. And that is our derivative. Okay, so now we're getting into the true purpose of the problem, and that's to minimize the length of steel needed to make this trap. All right, the most important thing that you have to remember, and this is every single one of these optimization questions, this is every calculus question that mentions the word minimum or maximum, every one. And so it's so important that you remember that at min or max points, the derivative is always 0. The derivative is 0. So it's going to logically follow every single time. Every single time they're going to ask you to differentiate something, and then they're going to ask for a minimum or a maximum. And it's a given, it's a must that you make your derivative, the thing you differentiated, equal to 0. That's a thing that happens all the time. So let's do it. All right, so we have from earlier that dt over dr is equal to this expression. So instead of dt over dr, I'm going to put, you guessed it, 0. Instead of dt over dr, I'm going to have 0. So 0 is equal to, and I'm just rewriting the right side of the equation, 2 pi plus 4 minus 12 over pi r to the third. Now they want us to show that r is going to be equal to 0.719. All right, so this takes some algebra skills here, and we're going to work through it. We just have to be confident and trust that the answer will come. All right, so we're trying to isolate our r. So let's get these things on the left side here. Let's get these things away from our r by adding 12 over pi r to the third to both sides. I like the positive sign, which is why I'm adding that and not subtracting the other two things, pi r to the third. So we're going to get here that 12 over pi r to the third is equal to 2 pi plus 4. All right, so there's still a lot of stuff with our r, but again, let us just try to be confident that this is going to magically happen for us. So we have a fraction on the left side, so I'm going to turn the right side into a fraction as well, and I'm going to cross multiply. You can do it that way, or you can just think about it as multiplying both sides by our denominator. All right, but either way, if you cross multiply or if you do the other thing I just mentioned, you'll get 12 equals 2 pi plus 4 times pi r to the third. So now we have a bunch of stuff with our pi r to the third again, but that's okay, because we can now divide both sides by 2 pi plus 4. Divide by 2 pi plus 4, and we get that pi r to the third is equal to 12 over 2 pi plus 4. All right, we are getting closer. We are getting warmer. I want to get that pi away from the right side. So I'm just going to divide by that pi on both sides. And we get that r to the third is equal to, let me clean this up here, r to the third is equal to 12 over pi, the pi that we just divided by, 2 pi plus 4. All right, I'm going to pause for a second so you can put that left side into your calculator. Okay, and so when you do, you should get that r to the third is equal to 0.37145 approximately. So we are getting super close at this point. All you have to remember at this point is the opposite of raising something to the third power is cube rooting it or raising it to the 1/3 power. And that's not multiplying by a third, but actually raising it to the 1/3 power. I am writing 1/3, but it's coming out looking like gibberish. All right, let's try that again. Raising it to the 1/3. Okay, so whatever you do on that side, of course, we have to do on this side. So raise your number to the 1/3 on the left, and you should get that r is equal to 0.719 meters to 3 significant figures. Okay, so at this point, when they're asking for the value of L for which T is a minimum, you're going to have to look back at all the work you've done so far. So we just figured out that the value, our value of 0.719 will give us a minimum T. And from question B and C, we figured out a relationship between L and R. So I will repeat just in case you missed that. We figured out that R that gives us a minimum T value is 0.719. And we also figured out earlier the relationship between L and R. So that's all we need in order to figure out the value of L that we're looking for. So since we know from part C that L is equal to 1.5 over pi r squared, well, we write that down and then we substitute our value for r. So our L is equal to 1.5 over pi 0.719 squared. And when we plug that in, we should get approximately 0.924. And our units, L is meters, or units for L is meters. Okay, so finally we're at the last part of the question when they want the minimum value of T. So I'm super excited here. We're almost there. Okay, so from part C, we learned that T was equal to 2 pi plus 4 times r plus 6 over pi r squared. They actually gave this to us. This isn't even something that we had to find. So we were given this expression, this equation, and in our part E, we found that the r that gives us the minimum T is 0.719. So all we have to do at this point is plug our r value into that equation, and we'll get our minimum T. So let's go ahead and do that, and we'll be done. So T equals 2 pi plus 4, just rewriting, times our r value, which is 0.719, plus 6, again just rewriting, over pi r, let's substitute that in, r is 0.719 squared. And once we plug this all into our calculator, we should get that T is approximately equal to 11.1 meters. And we're done.